we realize that the atomic number and the mass number is 1 and 1. Agreed?
Yes, sir.
Alright, and what can we deduce? Remember the main things that we need to know to draw the structure. We need the neutron, the protons, as well as the electron to draw the atomic structure. So give me each of these subatomic particles. How much neutron?
Sir?
How much neutron, remember from yesterday's class, how much neutron we have in the structure?
Let me check.
The table that we work out, you don't have it.
Oh, yes, sir.
Remember we did the 20 elements yesterday, we work out the neutron, for all the elements, So how much
Yes, sir.
neutron? How much neutron in hydrogen?
0.
0. Good. And for those who are wondering how we get that right, you can watch the video that's on the top right of the screen. Right? The link is on the top right of the screen, you will see that. The amount of protons, what did we say now? So remember, this is the top part is A, which would be the the mass number, sorry. And then the bottom part is Z, which would be the atomic number. What did we say again about the atomic number? It tells?
Sir?
What did we say about atomic number again? It tells what and what?
The number of protons in the nucleus of an atom.
As well as what?
Electrons.
Good. So if we know that, we can deduce that the amount of protons is what?
Sir? Repeat.
Right, so we know the atomic number is 1. Good. So
Yes.
now I'm saying, right, if the atomic number is 1, how much proton will we have in the structure?
None. 1.
Don't guess it, man. Don't guess it. Atomic number tells the amount of protons and electrons, right? So if the atomic number is 1, what would be the amount of protons and what would be the amount of electrons? Atomic number tells the amount of...
1.
Good. 1. And the electrons is 1. So what do we need to do now? We need to draw the structure of this atom. It should be hydrogen. So right, step 1. So we work out that step 1. Step 1 is up top, right, as indicated on the slide. Right, so we determine the protons, electrons, and neutrons. So this is step 1. So we're at 1 beside it. This is step 1. I know what, I'm not gonna write it because I don't want the viewers to become confused. So let's not write it. That is step 1. So enjoying the structure now. The idea is that, remember that we're gonna write the amount of P and the amount of N. Right? So remember the amount of N that we have in the structure is 0. And the amount of P is 1. So we write 1P and 0N in the middle. Then we're gonna draw circles around the nucleus, right, which represents the shells, the orbitals, the energy levels. Now, the first, as I mentioned, the first shell can hold a maximum of what?
2.
Good. And we only have 1 electron in the structure, so we just draw the electron on the structure, which would be that. Right?
Yes.
Or so it could be either one. You could use that. Remember, you can use that or cross, right? Which would be the one that I just drew as well as the dot, right?
Yes.
So this right here represent the electron. So we only have 1 electron on the shell. How would we write? What would be the EC now?
1.
Excellent. Lovely. So that would be 1. Right? So the EC would be 1. EC just tells you how it is arranged on the shell. So the EC is 1. What's next? So moving on to the... So what we're doing now, so this is basically how you draw the structure of an atom. So we're going to move on. So you get that?
Yes, sir.
Moving on to the second one. Now, what's the second element?
Helium.
Helium. All right, remember, so what we do, we just write the symbol for helium, which is He. Right, and then remember, we have to work out the amount of N, P, and E. How much N in the structure?
Sir?
How much N do we have in the structure of helium? Remember the mass number is 4 and the atomic number is 2. So how much N would have been in this? How much N would be in the structure now?
2.
You sure? Are you sure?
Yes, yes, sir.
Alright, good. So 2.
Yes.
And then the amount of protons.
2.
Good. Atomic number tells the amount of protons and electrons. The only thing that you should have difficulty with, it should be the neutron. Because once you look on the bottom number, the smaller number, or the smaller number on the nuclear notation, the atomic symbol, you should be able to determine the amount of protons and neutrons immediately in the atom. So once you look on helium and you see 2 down at the bottom as the atomic number, 2 being the smaller number, okay, from that I know that the protons equal to 2 and electrons equal to 2. All right?
Yes, sir.
Good. You can write on the book. You can write on this board or no?
Yes, sir.
All right. So as soon as in the latter part, I'm gonna allow you to do some. So just erase that. So you have N and P, and it doesn't really matter where you write the letter, right? In terms of, you could have P up top and N at the bottom. You just need to show that N and P is within the nucleus. So you have 2N and you have 2P, right? And then you draw the circle around the nucleus, which again would be the shell, right? And I said before, you can use a dot or a cross. So I'm going to use a cross for this one to represent electrons. So you can use either the dot or the cross, right, to represent. So this is the dot, is the full stop, right? D, I'm going to use D to represent that, and then C for cross. So for those who are watching, right, when you're drawing the structure, you can use either. And then remember, we have 2 electrons on the first shell, right? The first shell can hold a maximum how much again?
2.
Good. So if that, so what would be the EC now?
2.
Good. So you get this, you get in the concept. So the EC would be 2. All right, so let's move on to the other one now. What's the other element?
Lithium.
Good. And the symbol is Li.
Yes,
So
sir.
give me the mass number. The mass number is 7, and what's the atomic number?
3.
Good. So we have 3. Again, the subatomic particles, we have N, P, and E. How much N is within the structure?
4.
How do you know that? What did you use to determine that?
Sir, the mass number. Wait, no.
Mass number, and what?
Sir?
So you use the mass number and the atomic number to get the amount of neutrons, right? So it would be, again, I'm saying it a million times, right? To get the neutron number, it would be mass number. It would be A minus Z equal N.
Yes, sir.
N is the amount of neutrons. Mass number minus atomic number gives neutron. Alright, so we said the atomic number is 3, right? Protons would be 3, and the electrons would be what?
3 as well.
Good. What we need to do now, we're gonna move on now to draw the structure. Again, you have N and P in the nucleus, right? 4 for N and 3P. Alright, let me ensure that this is clear enough. Just ensure that the 3 is clear enough. So that's 3P. Alright, remember the first shell can hold a maximum
of 2.
Good. And then the second shell can hold how much?
8.
8, right? But remember, we only have 1 remaining out of the 3, so we just put the 1 on that shell,
Yes.
right? Because we don't have any more electrons. So the EC would be what now? What would be the EC?
2 and 1.
Excellent. So 2, comma, 1. So we just use a comma to show the separation of shells. Alright, so moving on now to the 4th element. Beryllium, right? So would be Be. What's the atomic number? What's the mass number for Be?
4 and 9.
Mass number 9, atomic number 4. So again, remember that we need to show the amount of P, the amount of N, and the amount of E. How much N we have?
Sir?
How much N in the structure?
5.
Good. And then the amount of protons?
4.
Good. And then remember the amount of electrons would be the same thing as well. So move on now to draw the structure. So the N and P, N equal 5 and then P equal 4. So it's again the first shell can hold 2, right? The second shell can hold 8, right? But remember that beryllium have 4 electrons. So that therefore mean when we write all electrons on the structure, right, it should be equal to the amount of electrons. 2 on the first shell and 2 on the second shell. So the EC would be what?
Repeat, sir.
What would be your EC? Are you following what I'm doing now? You understand?
Yes, sir.
Alright, good. So first, go again.
2 and 2.
Good. So 2 and 2. So that's 2 and 2. So that's the EC. And then, so that's for beryllium on the structure. We're gonna now move on to the other element.
Boron.
So for those who are watching, don't forget to like, share, and subscribe. Also remember that we have study guides, right? So if you want us to customize study guides for CXE topics, you can also reach out to us. Alright, and you can also spread the link. And also we have PowerPoints, right, for those who are in need of those stuff. What's the mass number? What's the mass number for beryllium, Morgan?
Sir, boron, I mean.
Sorry, my what? Boron.
11.
Yeah, yes. Good. So again, regular procedure, right? N equals
6.
So N is 6, P is
5.
5, and E is what?
5 as well.
5. So now we have to go ahead and draw the structure. Alright, again, N and P. So N is 6, P is 5. Alright, so remember the second shell can hold a maximum of how much now?
2.
2. Not the second shell can hold a maximum of
8.
8. right? So, and then remember when you count up all the electrons, they should be equal to the amount in the that you identified. So 1, 2, 3, 4, 5. And then we're gonna write the EC. So our EC equal, what's the EC?
2 and 3.
Good, so 2 and 3. Right, and then let's see if the other one can hold here, which would be carbon. Right, so carbon, what's the symbol for carbon again?
C.
Good, and then the mass number is 12. Atomic number 6. So N and P. How much N do we have?
6.
How much P, how much E?
6 and 6.
Good. Alright, so we have to bring over this a bit because it's too close. So let's bring it over a bit. Alright, so now we have N and we also have P. Small. Right, bigger so the number can fit inside. Yeah. And then we have 6 here as well. I remember the first row can hold a maximum of
2.
That's 1, 2, 3, 4. What's the EC now?
2 and 4.
Good. And one thing to also take note of before we move on to the next slide, right? We start with single first, then we start to pair. Good, so now I will show you that. So you start by placing electrons on 4 sides, 1, 2, 3, 4. Then you start to pair afterwards, just to make it organized, right? So it doesn't look untidy, right? So that's the principle. Not necessarily, I mean, something that help you to let the work be organized and for you to don't become confused. So we understand the basic principle. Now what we're gonna be doing now, moving on to the next slide. So you get it so far, Morgan?
Yes.
You understand what I go on so far?
Yes, sir.
Alright, cool. Alright, so we just finished carbon. Which one moving on now to? The next one after carbon is?
It's
So it's nitrogen, which would be 14 and 7, right? And then how much N, how much P, how much E?
all 7, sir.
Alright, so 7N, right? 7P and 7E. Now we're gonna draw the structure, which would be 7N and then 7P. Right, we'll place the electrons on the structure. And then what we do, remember the second shell can hold 8. Normally I recommend students, and you will see it highly recommended as well in books as well as videos. You start out single by placing the elements right on 4 sides, and then you start to pair. Right, so you can see it. So in this case, it's 1, 2, 3, 4, 5, 6, 7. Right, so I started off by 1, put 1 up here, put 1 here, put 1 here, then I start to pair them until the electrons are finished. Right, until you become a pro on it, you can start to pair. You can start out by pairing, but I don't recommend that if you're starting out. So it's 2 and what? What would be the EC? 2 and what? 2 and Morgan.
6. 6.
Nah, man, count that again.
Wait. 2. Oh, 5.
Yeah, 2 and 5. Why is this thing there? Yeah, man, so 2 and 5. So that would be the easy. Right. We're gonna see if we can finish the first 10. Right, and then we're gonna come back and finish the other 10. Because this session is almost over. Alright, so what comes after nitrogen? Morgan. You're sleeping, man?
No, sir.
Are you busy?
No, sir.
Alright, so oxygen comes after nitrogen, right?
Yes, sir.
Alright, how many N, how many P?
8.
Good, so 8 N. And how many protons?
8.
Good. Let's factor in. So that's that. Let's go. So the first shell was 2, right? And then my second shell, the second shell of the atom was 8, the maximum of 8. So again, I start with single, like I recommend, as I might recommend for students, right? And then afterwards, you'll start to pair. All right, let's move on now to the other one, right? So which one comes after oxygen?
Fluorine.
So F. So, and F, what's the mass number for F again?
13. No, 19. My bad. 19.
And the amount of N would be what? What's the amount of N? What's the amount of P? What's the amount of E?
Protons 9, neutrons 10, and electrons 9.
You're following the concept so far, right?
Yes, sir.
All right, good. All right, so the first shell can hold a maximum of 2. Second shell can hold a maximum of 8. So let's see if this one is completely filled with the 8. Remember, after I start with single, I start to pair. 2, 4, 6, 7. Hold on. 2, 4, 6. 1, 2, 3, 4, 5, 6, 7. Good. So what's the EC now?
Sir, we're trying to reach fluorine.
Yeah, what would be the EC? Fluorine reach.
2 and 7.
Yeah, good. So let's see if we can finish the 10th one before the session expires. What's the 10th one? What's the 10th one now?
Neon.
Neon. What's the mass number again?
20.
And then we know the atomic number is 10.
10.
Alright, so the N, what's the N, what's the P, what's the E?
All 10.
Good. So we're drawing the structure, right? Again, you have N and you have P. So we have 10N and we have 10P, right? So that 2, and then the other one, right? So we realize that this shell is completely filled, right? And that's that with the noble gases. The EC now would be 2 and 8.
Yes, sir.
Get that?
Yes, sir.
All right. Any questions so far?
No, sir.
All right, good. For those who are watching this video, again, don't forget to like, share, and subscribe. And also spread the link, right? In the coming video, we'll be doing part 2 of writing the structure, drawing the structure of the first 20 elements. Until next time, peace.